Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong, AWS, and GitLab. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and I'm pretty sure you will, we want you to send those in to us using the Q&A tab. You'll find that Q&A tab on the right side of the screen, where you'll also find the chat tab. We want you to use the chat tab to get to know your fellow audience members or let us know your thoughts throughout today's program. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's program. So on to the topic of today's program, Git Workflows for Platform Engineers. And I'm joined by Lee Faust, Global Field CTO at GitLab. Lee, thank you so much for being here today. Do you want to go ahead and take us through?
Yeah, thank you so much, Cody. I'm really excited to be here today. This presentation that I'm giving comes from a long history of working with Git, from software engineers to operations, and now working with different platform engineers. So a little bit about myself. My name is Lee Faust. I have been with GitLab for a little over a year. Before that, I worked for a small startup that was supporting the open source Spinnaker project. Before that, I spent 4.5 years at GitHub. And before I worked at GitHub, I spent 5 years running my own consulting practice where I worked with Fortune 100 companies, going through a lot of these workflows that we're going to talk about today. Sometimes we were using different SCM tools, but a lot of the techniques that we'll talk about today still hold true. So as Cody mentioned, if you go into, I'll be going through these slides probably in about 30 minutes. And as I go through those, if you have any questions about certain slides, please don't hesitate to throw a question into the Q&A section, and we'll make sure that we cover them at the end. So the first thing is understanding platform engineering. I remember when DevOps first came out, and we had a lot of different definitions, and it meant different things to different people. So this is the way that a lot of our customers at GitLab are presenting their platform engineering teams to us. So today, there's a cultural shift going on inside of a number of organizations. That cultural shift is being driven out of a traditional project-driven, task-based mentality, and now moving into a product-driven, value-based model. Now, that culture that is coming out of that forces us to think about DevOps, where most people will see DevOps represented as the infinity symbol. And in that infinity symbol, we talk about all the different steps of the software development lifecycle. So where does platform engineering actually fit in that model? Well, we're actually seeing it be an extension, if we want to talk about that on the right, where platform engineering is when we go and use a DevOps methodology around using all of these different tools in our tool chain. It's about the platform engineers understanding how to stitch those together, but at the same time, what data do I need to collect out of that tool chain for me to effectively report back to the new team around product operations, which is where my product management team lives, to know where are my high value applications, where are my low value applications, where are my higher performing teams, where are my lower performing teams. There's a very famous quote that came out many years ago where people talk about you can't manage what you don't measure. And we're getting to a point that we're wanting to be able to measure things from the first task that gets created all the way through to the change that represents that task. And then once that change is created into an artifact, how we get that artifact into production. Now, we know that there's a many-to-many relationship between a lot of these things. So am I deploying to EC2 on AWS? Am I going through an app modernization? And am I breaking this application into microservices? And am I deploying that into EKS? And all of those different combinations, permutations, makes it really hard to really narrow down where high performing and low performing applications really live. So how do we go ahead and build out an organization to think about these things strategically? So the first thing that we talk about today is when I go and I talk to people about DevOps, they normally talk about automation. And when they talk about automation, automation is a transitional item to getting to that platform engineering product operations mentality. And we see these things where we still have traditional ITSM type of building blocks around application engineering, application operations, platform engineering, and platform operations. All of these items are segmented. We're using DevOps to try to pull these four teams together. Part of the platform engineering teams are around building security around the platform. And then we've got application engineering and application operations. We're now building security into those. And a lot of that application security is being driven through the shift left movement. Now, as we move into what we're seeing today, is these teams are now moving into a product operations and platform operation model. So we no longer think about applications as standalone entities. It is now a product, and a product may actually be made up of many applications. So I need to find a way to aggregate all of those applications into a product-centric mentality. And then measuring as we release the product, which is the aggregate of the changes across multiple different applications. So you can think of in a traditional microservices application, if I'm in a highly regulated industry, a lot of times we don't just release an individual microservice. Usually there's dependencies between other microservices. Sometimes there's a database change. Sometimes there's a new API that needs to go to the API gateway. So we release those things in tandem all at once. And when we release those things, we release them as a set of items that we know what we plan to measure before they get released. The next step where most people are building out these models is if I get really good at platform engineering and I know what I'm measuring, I can get better at figuring out where those high value, low, high value versus low value applications live. And the platform engineering model has been completely automated from a perspective that I can start to determine which applications I've migrated into the public cloud are ready to automatically go in and do app modernization. We're seeing this with a lot of tools today where I can migrate an application and there's tools that we can run that says, oh, by the way, there's 14 different services running on this single VM. Would you like me to break them apart into multiple VMs? Would you like me to automatically create containers for each one of those different services? Would you like me to aggregate these to using cloud native services? This is where a lot of our customers want to get to. And this is how we scale product operations and platform engineering. Now, when we go and work with the executives who own the budgets for thinking about product operations and platform engineering, we really have to focus in on the people, process, and technology of all of the things that are being touched in this environment. One of the things that I've seen, both from an agile perspective and from a DevOps perspective, and I don't want us to lose track of some of the mistakes that we've made in the past. When we had agile, Atlassian came along and gave us Jira. And people said, if I'm using Jira, then I am doing agile. And that wasn't true. Agile was a methodology. And then we had a lot of tools come along and we talk about DevOps. And they said, well, if I just implement this technology or this technology stack, I'm doing DevOps. And what we really want to get to is we want to get to a level of bringing in the people and the process into this technology and using a requirements-driven approach before we ever can transform. So the two the developer engineering side the value drivers that we see out of being able to create this value-driven approach is improving developer onboarding and efficiency and building high-performing teams. And then the two operational value streams that we're getting is securing the software supply chain and creating a secure on-ramp to the public cloud. So enough about the precursor of thinking about what we're going to try to do and how can we actually implement this in our world today. So the first thing is to understand that there are traditional engineering workflows that we go through. Now, when I talk to platform engineering teams and I ask them, where do they get their requirements? A lot of times they'll get their requirements from a ticket that lives inside of something like ServiceNow or Jira, or maybe even Jira Service Desk. That's fine, as long as you're gathering requirements for the change that's being asked of you to go and implement. And this can be as small as, hey, I need you to modify a security group, or I need to create a new VPC, or I need to create a route between two VPCs, or I need to extend an API gateway. Those are all issues that should get created so we can track the change that's going to be represented by that. Now, when we do that, we need to understand that the change that we want to implement needs to be done in code. We don't want to go into the AWS console and start pointing and clicking to go make those changes internally. We want to use things like the AWS CDK. We want to use CloudFormation, or if your company chooses to, you can even use things like Terraform or Puppet to be able to make those changes. As long as we have it as code, we can create a chain of custody between the issue, the change that we're about to impact, walk it through a dev test, and then eventually roll it out into production. And those changes can follow along with the developer changes in line with the projects that they're currently working on. Now, this can sometimes be one of those items where we have a bit of a sticking point. Where do I keep my infrastructure as code? Should I keep my infrastructure as code in a separate repository that only my platform engineers have access to? Or do I go ahead and bring that code and have it live inside of the developers area with the changes that they're making? With a lot of the changes that are going on at GitLab today, what we recommend is that you incorporate the changes in with the development environment so we can build automation for when we go through the life cycle. I can then provision, configure, and deploy all of those changes as a single unit of work. That is the goal of platform engineering, is to get that type of visibility and then being able to create the measurements around observability, capturing metrics, being able to know what's my mean time to recovery. All of that data feeds back into product operations so they know how frequently is that application being used. Do I need 99% uptime? Do I need 99.9% uptime? And those things will end up driving things all the way back into support to know what are our SLAs, SLIs, and SLOs. So here is a typical makeup of how our customers will set this up. So inside of GitLab, you will have a group, and that group is the topmost element inside of GitLab that allows you to create sort of like a file system inside of your group that you can start to take advantage of breaking things up into smaller sections. So what I can do is I can create a platform engineering subgroup underneath Acme that will have its own set of role-based access controls. And I can take that platform engineering subgroup and map it to a team that's coming directly out of OIDC, coming out of LDAP, coming out of Active Directory. So I'll know who should have access to this. And that happens automatically during onboarding of a new platform engineer into the company. Now, underneath that platform engineering subgroup, we're going to create projects. And what I've seen inside of a lot of companies over the last 10 years of working with Git is I see these companies trying to create these Git repository templates. And what they will do is they'll try to include everything that could possibly be used and then ask people to delete it. And it never gets deleted. And it creates a lot of confusion. There's a lot of stuff inside those projects that we actually don't need. Now, one of the things that I love about the work that AWS is doing right now is through working with different customers, they are now creating templates that they will share out to the public community. One of those is what we call the Landing Zone Acceleration Project. So if you haven't looked at what the Landing Zone Acceleration Project looks like, I highly recommend doing a simple Google, going out there. It's going to create an area for you to be able to deploy items into it on an account by account basis. So I can create, when I create a commercial banking application, let's say, that application has a single ID that gets mapped back to what resources the commercial banking app is going to need. So they can't just go out and provision every resource inside of AWS. They're going to be dedicated to running certain services. And when they want to make a change, they're going to create a ticket inside the platform engineering team, and they will bring those changes with them into that particular project. Now, along with the landing zone concept, if you aren't familiar with this, have fun with your AWS rep. I love doing this with different people, is walk in and ask them to carve out an area of AWS for a non-production environment. And the AWS folks will laugh at you and look really confused, like, well, this is what I do in my own data center. Why can't I do that inside of AWS? Remember, there's this shared responsibility model inside of AWS. Their SLAs for a particular service is the same no matter if you think it is non-production or production. For them, it is always production. So now, once we have that landing zone project brought in and we configured it to the services that we know we're going to need, we then can create things like Spring Boot, Python, React. These are our developer templates. This is where platform engineering would work with the enterprise architecture team, maybe a solutions architecture team, to create what they want as a baseline. And this will include certain things like what version of Spring am I going to use? Am I going to use Gradle or Maven in the case of Spring? For Python, what version of Python are we going to support? For React, where are my NPM packages? What sort of security do I need to make sure that we're not including dependencies that are going to be insecure? And then we create subgroups inside of that platform engineering team based on the different targets that we're going to create, and we're going to create best practices. Now, what I can do is for things like EC2 or Lambda or ECS or EKS, I can then, inside these subgroups, I can isolate what I want to do in EC2 to make sure that I've got the right sets of dependencies for the AMI itself. And then I can use a project where I could be using Ansible playbooks that are then going to be pulled in based on, hey, this is a Spring Boot application, so I want to make sure that Java is then configured on this particular VM with the right settings for SE Linux, for other items, to make sure that there's firewalls in place and making sure that people only have access to certain directories when they potentially SSH into that VM to be able to see logs or being able to see other things. You can also have things automatically set up inside the EC2 project for streaming logs to something like CloudWatch or something else. And then we use these projects as project templates to then create the projects on the right. So underneath the commercial banking application, I've got my backend, front end, mobile. So all of these things usually make sense when I show it to people. Now, the question is I've got a backend project and I want to deploy it to EC2 with Java 17. How would I go ahead and do that without losing control of the EC2 project on the left, while keeping things updated on as we need to change things for EC2 on a project on the right? So here's the first command that I can do. So I'm not going to go through the basics of Git. This is more of an advanced Git class. So If there's things in here that you don't know, feel free to go out. There's a lot of really good Git books, but we're going to go into doing some more advanced Git techniques. So I'm going to clone 2 different repos, and these repos are both publicly available on GitLab that you can go out and see how I'm doing this. So I clone these 2 repos, and then I CD into the backend API. When I CD into the backend API directory, I now can see that this is, if I've got ZSH set up properly, I'll see that I'm in the main branch and that this is a Git enabled folder. So what I'm going to do is I'm going to create and add a new remote. Now, what a remote does is it's a pointer to another Git repository. So I can remote add, and I'm going to say, I'm going to give it a name called EC2, and then I'm going to point it to the EC2 directory that I cloned from up above. The next one, there's a section at the end of the command. I'm going to merge these 2. And if you look on the right, I'm going to allow unrelated histories. This allows me to import the history from the other one. So at any time, if I want to bring in new changes from EC2 main, I can keep that SHA history in place so I can always keep it updated from changes that you may make on that left-hand side of that graph from the previous slide. Now, if I do this merge in this way, it's going to automatically try to merge all of those changes. And it's going to put everything into the same directory structure. So here you can see my git ignore, my GitLab CI file, my README, all of those try to get merged automatically. This is probably not what you want. You're going to end up with conflicts, probably a lot of conflicts, and then you're going to end up in a merge state that's going to be very hard for you to get out of. So let's look at a better way of solving the same problem. So here, because I now know that a remote is just a link or a shortcut to another Git repository, it doesn't have to be a repository that I've cloned locally. So first thing I do is I CD into my backend API, into the repository that I've cloned. Now I'm going to add a remote to the EC2 folder on my server somewhere. Now, when I go ahead and do that, I need to fetch from EC2 so I know all of the branches that are available. This is something we're going to come back to in a few slides. So now when I git merge, the -s says, what type of strategy am I going to use? And I'm going to say, when I merge, I want you to prioritize my files over the files that are in EC2. The other thing I'm going to do is I'm going to do a no commit, because what I don't want to do is I don't want to create a commit merge. I just want to be able to stage my changes. So I'm going to stage them, and then I'm going to do an EC2 main, telling it what branch I want out of EC2 that I just fetched. And now I'm going to allow all of the unrelated histories. The next thing I'm going to do is I'm going to do a git read tree, and I'm going to set a prefix to .aws. Because I haven't committed my changes in the previous line, the .aws is now going to have a folder that I'm going to put all of those changes into from EC2 main and tag them into that .aws folder. So now I'm creating a new folder inside the existing Git repository where all of those files from EC2 main are now going to live. So now I can do my commit. And when I do a commit, if I CD'd into .aws/EC2, I would now see all of the files that I want. Now, anybody who has done any sort of Git development in the past will see there's a problem here. Your developers are going to slap your hands. They're going to say you should never push your changes directly into main. So the optimal way when working with development teams is we're going to start, and the first 3 commands are going to be exactly the same. What I'm going to do is now I'm going to create a new branch. So I've got this infrastructure. So for developers, they're going to have branches that they're going to call bug fix. Maybe it's bug. They'll have one called feature. They're going to have their own branch naming conventions. So why don't we create one for our infrastructure team? Maybe it's platform team, whatever we want to do. So we will create this new tagging mechanism for our branches, and then we're going to give it a name. So we're going to say, I'm about to merge all the EC2 data into this particular directory. So now that I've got this branch, I'm going to fetch the EC2. I'm going to do the merge the same way that I did before, do the read tree the same way that I did before. But now when I commit into those changes, all of those changes are now going to live in that new branch. Because I have this all in a new branch, what you'll see here is this is my favorite tool. If you are not a Git expert, you're not a big command line person, this tool's for you. It's a tool called Tower. So on the left-hand side, we can see we have the main and the infrastructure. Merge EC2 is our local head. And then I can see the two different remotes. So I can see origin, which is the origin for the Spring Boot project. And then I've got EC2, which is the origin that I have for the EC2 that was on the left-hand side of that original graphic. So because I've got two different remotes, as long as I don't change these remotes, at any given point in time, you can continue to pull changes from that EC2 folder into that existing EC2 directory. So now the platform engineering team can continue to work and modify and update the EC2 directory independently of what I'm doing on the development side. And I can continue to merge those two concepts together while keeping the development teams always in sync. So now the platform engineering teams, your SREs, your operations, the development teams, QA, the all of your PMM, everybody else is now sitting in the same repository, in the same project, and they can all see the changes that need to go on. Because I'm in a branch in GitLab, I can now create a merge request. And what a merge request allows us to be able to do is I'm going to stage my changes and I'm going to start a conversation. So why would I do this? Well, a lot of times I see platform engineers are sort of stuck on an island. So they go grab their ticket out of ServiceNow, they sort of go off and do their work, and then they go ahead and they just do those changes in isolation, and then they go and close their ticket. There's no collaboration, there's no learning, there's no, hey, I've got a better way of solving this problem. This is what a merge request is for. Not only that, but you can incorporate other best practices into this merge request. So I can do things like making sure that I do have reviewers. There are other things that I can do around ensuring that I've got labels. So I could have an infrastructure label to this. So now I can group things inside of a Kanban board and say, show me all of the merge requests in this given change set that are focused on an infrastructure change. So everybody is on the same page as to the new change that's about to go out. What are the related infrastructure changes and code changes that need to go out together rather than trying to go off and create multiple different reports and creating an Excel spreadsheet to be able to know who needs to make what changes when. This is also really powerful when you want to do things like a database change. So we've got this infrastructure branch. I could have a database branch. And now I could be updating the schema, and I could have all of my database platform definitions in a directory, just like we did with our EC2. So I'm keeping these things independent, but I'm tying them together in the project itself. So now that we've got these things in a merge request, everybody knows that this is where we kick off automation. So a new change has just come in. And now with this change, I want to make sure that I can trigger my automation to be able to push these changes into dev test. So when we had our original project set up for EC2, for you to do your testing inside of GitLab, you would have done all of your testing using GitLab CI or through the automation that exists inside of GitLab, and you would have done it in isolation. So you're only going to be seeing how that particular image gets created. When I get to a point that I want to incorporate that into the project itself, what I can do is I can go to the GitLab CI file, and now I just create this new include where I say local, and I say .aws, which was the directory that we imported all of that EC2 definition into. I do a ** using regular expression, so I don't care what directory you're in. So I could have EC2, ECS, RDS, API Gateway, and I'm going to get the individual GitLab CI files in each one of those folders aggregated together. So you can see here on the right-hand side of my screen, you can see that our GitLab CI file just for EC2 is using Terraform to be able to go through all the different stages of init, validate, plan, apply, and destroy. So when I incorporate those, they're automatically going to show up as a merged YAML file for this project when I go ahead and go to deploy. So now when you go into GitLab and you look at what this is going to import, there's this feature on the left-hand side for you to be able to see right next to where it says infrastructure merge-EC2. You're going to see a little tree view button off to the left. That allows me to expand that toggle that shows me all of the includes that I'm going to be bringing in. So here we can see that that regular expression that we created is bringing in all of the .aws ec2 .gitlab-ci YAML files. So again, if you were concerned about, hey, how do I know when I use that regular expression, am I including all of the right files? This is where you would go to be able to see how those things are all going to get aggregated. On the right-hand side, you're going to see a View Merged YAML tab. You can click on that View Merged YAML tab, and it will show you what the aggregate of the entire CI file is going to look like. So now when this gets ready to execute, what we'll see here down at the bottom is now I've got this included that now I have a build stage, I've got a test stage, I've got a publish stage. So this allows me to create my jar from a developer perspective. But then once I create that, I've got an init, validate, plan, and destroy for all of the infrastructure. Now, all of these things go into different stages. So I could, instead of having a init, I could move the init into the build. So now I can be creating my infrastructure environment while at the same time building the application. And I can tie these things together using statements like requires or needs, and those have different meanings inside of GitLab. And you can then have job dependencies. So I can say, hey, I'm letting you know that if the init fails as part of my CI job, I don't want to continue any more of the executions for validate, plan, and destroy. So those things now can also keep me from doing a test and publish. That way I can keep my infrastructure changes tightly coupled to the changes to the application. So I know those things are going to go out simultaneously. A lot of people are reading a lot today around securing the software supply chain. This allows us to be able to create IBOMs, so our infrastructure bill of materials, while at the same time creating SBOMs, so we can have our software bill of materials. I can now create those two items aggregated together as part of a set of release notes. So every time we go out, we'll know if there was an infrastructure change to be able to support a new release of the application. Why might this happen? I've got a database change. Maybe I needed to increase the amount of memory on the VM. Maybe I had to create a new namespace inside of a cluster. All of these things right now, we can even do when we think about going towards EKS and doing Kubernetes. There's things you may need to do using the API, and we can leverage functionality inside of GitLab and using the same technique for being able to do things around GitOps. So I can have a standard set of manifests for Kubernetes that are going to be templatized in a way where I'm going to use the project name. I'm going to use environment variables that we're going to ask the development teams to set. Those now become templatized in the exact same way we're doing this for EC2, and allows you to be able to have a standard set of manifests for every deployment going out into Kubernetes. And then we just monitor those files using our GitOps capabilities and our agent for Kubernetes. And we can automatically update Kubernetes as application changes happens, CRDs change, secrets change, a Helm chart changes. Any of those things will automatically update our Kubernetes environment on the fly. Now, from here, we've only had a finite amount of time to be able to talk about these different things. There's a lot of other things. If this is intriguing to you, some learnings that you may want to take is sometimes the projects that we have on the development side, the repositories just have a ton of files in that you really don't care about. So you can do things like a sparse checkout and just check out the .aws folder and just work on that inside of the individual project. You may have other things that you want to do that are one-offs that you can then track inside things like parent-child pipelines. So I might not want to build and deploy in the same set of steps. So I can say only when I get a good artifact and that artifact has been scanned for security and all of the other components around policy management, I'm going to use a workflow to then kick off a child pipeline that could live in a different EC2 folder. So instead of me importing that particular YAML file, I can actually, instead of doing a local, I can include it as a remote, and I can tell it actually lives in a different repository. We can also do things like leveraging code owners. So I can now incorporate people that I want to review all of my .tf files or all of my .template files. Those things now end up living in a way that I know that somebody's going to come review my code, so I'm no longer living out on an island. And I can also use branch protections to ensure that those reviews are taking place and ensuring that we have things in place for auditing and compliance, like making sure that we have a separation of duties. And then there's a capability inside of GitLab called environments. So this way I can stage changes. You might want to have one environment for staging infrastructure changes and another one for staging all of your application changes. You may want to blend those two together. It's completely up to you using environments. And then there's some advanced paid features inside of GitLab, like we can manage your Terraform state and manage your Terraform modules directly from inside the project where they were created. I can also use things like compliance pipelines that ensure that certain things always run as part of your automation steps. And then I can even do policy management using things like OPA. So I can ensure that, hey, I'm not going to allow you to merge into main if I have any critical issues open inside of my project. So these are the things that I'm hoping strike a little bit of interest in how can I use Git and how can I take it to the next level as I'm thinking about collecting the data for my different projects so I can feed that data back to my product operations teams so we can build a better product portfolio and know which applications require the most help in the future and ensuring that a good, healthy relationship is built across all of the different teams. So with that, I am going to stop the sharing and see if there are any questions.
Hey, Lee, so we have received just a couple questions, and I'll also take this time to remind our audience, do send in your questions. We've got about 20 minutes here set aside to address anything you've got. So, Lee, do you have product platform owners or a product team?
Oh, wow, that's a great question. I think it depends on the organization. The larger the organization, you're going to need to break those things apart. The one thing that you want to make sure of is what I'm seeing with teams that have, let's say, a DevOps team. What they're doing is they're breaking apart the different steps of DevOps and they're creating additional silos. So they're creating an automation team inside the DevOps team. They're creating a security team inside the DevOps team. And that is removing the whole goal of DevOps, which is to break down those silos and trying to pull people together. So the easy answer is trying to keep that model as flat as possible, but still being able to achieve the goals on the back end. So unfortunately, I'm going to give you the architectural answer for that is it depends. But keeping that as flat as possible and knowing what requirements you actually need to gather. Also, it goes to the number of products that you're going to have. So for a company like GitLab, you could say only has one product, which is GitLab. Well, there's also a number of sub-products that live underneath GitLab. So as you think about that, how do I aggregate these things together into like parent-child relationships and who owns what? Those are things that usually go into understanding how you do portfolio management, and that would also drive part of that discussion.
Awesome. So this next question, I'm going to go ahead and pop up on the screen because it is just a little bit long, but I'm going to go ahead and read it out loud as well. Is there a framework or a list of already built guardrails a company can implement in the test phase to ensure dev or platform engineers don't just create unsecure infrastructure? Example, two wide security groups, IAM roles with wildcard permissions. The starting point might be AWS CloudFormation guards, but this means a company should start from zero.
Another great question. So there are a number of companies that are out there using my favorite framework for this is the Open Policy Agent. And the Open Policy Agent is an open source project that is supported by another company called Styra. And Styra and GitLab work very closely together. Now, what some people will do is they will go ahead and extend OPA, they have what they call Rego files. And those Rego files are how we define those policies. So there are companies that have gone out there and used those Rego files to define best practices. I am officially part of a group inside of what's called Finos. So there is something called Cloud Service Certification that they're building as an open source project for all financial services companies to build those guardrails for any public cloud service. So what are those guardrails that I can just consume using, there are some requirements. So you have to use Terraform and you have to be using OPA. And then those two things, if you choose to just consume them, then you can automatically have all of the guardrails pre-built. There are other companies that are out there that are not doing it in an open source fashion where you could go out there and just pay for their Rego files and they will give you a standard set that will get you probably to 80 to 90% of the best practices that are out there, and then allowing you to be able to extend that to any specific corporate type of governance that you need for your specific use case.
Awesome. Thank you so much for that, Lee.
Yep.
How would you ensure that the team managing the EC2 ECS repo isn't the bottleneck of the organization?
Unfortunately, I am probably that person who is usually the bottleneck. So I feel like this is somebody who is out there who knows me personally. When you're doing this is you need to have a strong platform like GitLab where you can cross-link requirements between projects and then having those items be listed as blockers. So a lot of the people that I know, they have site reliability engineering members in the product teams themselves. So they're not in every meeting, but they're sort of like a dotted line to that product team. And when there's a change, they will end up creating a ticket for the person or an issue with the requirements in the EC2 project, and then have a merge request or have another issue that is living in the project itself that has a blocker linked back to that other ticket. So that way, the person who's working in the EC2 directory, in the EC2 repository project, they know that they have a blocker that is outstanding that I'm not going to be able to move forward with my product until the EC2 project completes that particular task. Now, a lot of times the question comes up is, well, I don't want those changes in my EC2 project. How do I keep those new changes and my changes unique? Well, you have two choices. One, the SRE could just make the change themselves in a given branch inside that project that they're currently working in and use that branch as a testing harness that they want to use. Remember that remote that is configured, if the person who is now in that project, they can push changes to that remote as well. So if they have read write, they could simulate those changes, go into dev test, see that it's working, and then send that change to the other repository as a choice. So this gives a lot of flexibility to where I keep repositories and where they live, and being able to keep things in sync while still making recommendations of a particular change. The thing that's kind of interesting about this is in that model where if I push that change into the EC2 directory in EC2 project in a given branch, I can now start a merge request in EC2 with the person who owns it, tying it back to the blocker and saying, hey, what do you think? We've got this working in dev test. Anything you would change? Now I'm putting it back on them and saying, look, I've already started this and I've got it working. It's up to you to tell me if I'm missing anything from a best practices perspective.
Awesome. And the participant that asked that question did say, I'll have to review the repositories, but thanks for the content. Food for thought.
Great.
So we do have another question here. There it is. How can you compare this workflow with Git mirroring using code pipeline?
So Git mirroring is a little bit different. So Git mirroring is going to be a one-to-one change using webhooks to allow you to keep the code in sync. And a mirror is, in a lot of the different products, it's not a two-way sync, and there can be latency related to it. So if I'm doing code mirroring in something like code pipeline, what you're going to end up with is, now, if you're also using the other CodeStar projects inside of AWS, latency probably isn't going to be an issue. But the mirroring doesn't allow you to be able to have multiple remotes. So you're going to have to choose one remote that you are always mirroring off of. Otherwise, if you're going to try to do it in the way that we just described, you can do it, but you're going to have to review how to do it with submodules. So now you can have submodules, which is another way to simulate the work that we've done, except there's a little bit more, it can be confusing as to where the changes actually reside, because you have a root project and then you have like sim links to other projects. So, and then you have to do things like enabling submodule support and for mirroring, and you're going to have personal access tokens. And there's a lot of things that sort of lean towards some security no-nos that I know, working in regulated industries, that people are going to slap your hands for and say, stop doing this.
Well, that is all the questions we've received so far. So to our audience, if you do have any more questions, now is the time to send those in. But Lee, do you have anything that you'd like to let our audience know before we close out? Anything else you'd like to dive into in these next few minutes?
The big thing for me is, this is just a suggestion. This is what I've seen work. I was actually kind of surprised. This talk actually came out of going to a number of different AWS summits, where I would get a lot of people asking questions about best practices around organizing project templates. And what really surprised me about that is a lot of people don't know about these advanced Git techniques. So everybody knows how to clone a repository, how to create a branch, how to commit code, and then how to push back in, but they don't understand the Git database itself. Remember, Git does not understand anything about files. It's a database, and that database knows how to assemble the file system structure in a way to be able to represent change. I really think in a time of today, if you are going to be using these techniques, is to understand how Git really works. And go grab a good Git book, go on O'Reilly, go somewhere to be able to get advanced and play around with some different commands. Things like sparse checkout can do all kinds of really interesting things. Um, uh, Other things that you might want to be able to do are when we start talking about those ref trees, there's all kinds of things you can do around trees and making sure you're only getting certain change sets. So I highly advise learning what some of these other, I have a talk, if you do a Google search, there's probably, if you look underneath my name, I had a how to undo almost anything in Git. So if you get stuck, there's usually a way to be able to back out your changes and get back to a current working state. So don't be afraid and dig in and play around and find what works for your own company.
So we do have someone who's interested. If you have any specific links or really any books you could recommend.
So there's a book by Scott Chacon. So Scott Chacon was employee, I guess he was officially, after the founders, I believe he was employee #1 at GitHub. And he wrote what everybody will call the Git Bible. His last name is Schacon. You can probably find it on Amazon. It's also available online for free. That is usually what I use because it has a great search for me to be able to go through and try to find specific things. So that would sort of be where I would start from a book perspective. There's also some really good trainings out on Udemy and some of the other public places where they give you like a little sandbox for you to play with more advanced Git commands.
Awesome. Okay, we've received a couple more questions. So how do you recommend hardening Git versus attacks?
Ooh, so like when it lives in a SaaS solution like GitLab.com or GitHub or Bitbucket, they usually do a pretty good job. The one thing to understand around securing it, if you're using, let's say, GitLab self-hosted, if you're going down that path, then what you're going to want to do is learn from what the other players are doing. So if you're looking at attacks is to make sure that, let's say you're going to do Git SSH. Well, don't do Git SSH on port 22. That's sort of like rule #1. You should run SSH on a different port for Git SSH. And that's configurable inside of GitLab and some of the different settings. The other things are making sure that there are specific routes that you only allow through your firewall. So like for Git repositories, you only want to allow things with a .git as an endpoint that have there's a header that comes across if you're doing HTTP, there's a header that comes across to let us know that it is a Git repository. So you can do things at your firewall level to be able to make sure that you can block things inside, let's say, your CDN or inside your DMZ to only allow certain traffic to access those Git repositories. And then things that from a security perspective are ensuring that users do things like 2FA, really basic things, ensuring that things are that they're not just using basic username password combinations. It's tied to some other third-party IDP. Those are some of the things to be able to secure those. The downside of Git is, remember that Git is a distributed database at the end of the day. So once somebody does clone that repository to their local machine, you're kind of out of luck. So if you have things like you have laptops that you give out to your employees, you can then do things with products like Sentinel and other enterprise management tools to say, hey, if somebody tries to push code to a .cn endpoint, so to another country that you don't want IP leakage to go to, you can sort of keep them from being able to do that by having that local firewall on the laptop itself.
So, can you give a top 3 list of security no-nos, and are personalized access tokens part of that top 3?
So personal access tokens is in the top 3, but that's with a caveat. So the personal access tokens need to have an expiry date. I know that personal access tokens are the way that we use shell commands and things to be able to automate things inside of our environments, but you should use best practices like we get from different organizations that say, hey, you know what, these tokens should rotate every 60 days or every 30 days. So make sure that you set a reasonable expiry for those. Don't let them live on forever. You can the downside to personal access tokens is people can create personal access tokens for bot users. So if you do have a bad actor inside the organization, they can create a user who is outside of that IDP and then create a personal access token that if they did get forced out of the company, they can get access to the code using that bot user using the personal access token if it hasn't expired, and you would have no idea that that bot user is actually the other user because the other user should have been removed from the IDP once they leave the organization. The other one is this is a common problem is ensuring that people do not push secrets into their repository. So there's lots of different tools out there. GitLab directly has it in our Ultimate suite. I think it's in Ultimate, it might be in Premium. We can keep you from uploading secrets, and we'll look for certain files and certain directories on it's a pre-receive hook, so we can make sure that those secrets never even make it into the repository. And then if you have secrets that are in files that we don't know about, we will then scan them post-push, and then we'll be able to remove those. We'll ensure that you can't merge those into a main branch, and make recommendations like, hey, now that this is in this repository, you should go rotate your keys. And then the last thing that I would say is basic role-based access controls. We have a tendency to, and I don't know what it is with Git. I don't know if it's because of the distributed database nature of it. We have a tendency to trust people that we probably shouldn't trust. So we have a tendency in our organizations to give people broader access to things that they shouldn't have access to. So, and we should be turning off certain capabilities for projects that don't need those capabilities. Like inside of GitLab, if I don't need you to be able to work on issues and I don't want you to have any agile planning inside of it, then turn it off. Don't give people the opportunity to potentially put stuff into a project that doesn't belong there. So ensuring that you can turn certain capabilities on and off is critical to being able to make sure that you're securing things in a way that people only have access to what they need.
Awesome. Well, Lee, thank you so much for running us through GitLab and really running through the gauntlet of questions that I just put you through. I really appreciate all the in-depth answers that you provided for all of our audience members, and we got a lot of thank you messages in the chat. So really appreciate that.
Great.
I would like to remind our audience that today's session was recorded. So following this program, you'll receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. I also mentioned at the top of the hour, we'd be giving away 4 $25 Amazon gift cards. So our winners are Abby S., Mateo A., Jamie S., and Kareem G. To our 4 winners, congratulations. Keep an eye on your email inbox to claim that gift card, but if you do not happen to see that email, just check your spam folder. I would also like to thank AWS and GitLab for sponsoring today's program. And to our audience who spent the last 60 minutes with us, we really appreciate you being here and your feedback and your questions and your chats. We do just want to ask for one extra moment of your time to fill out a brief survey that will pop up on your screen as soon as we close out. But otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, everyone. And Lee, thank you again so much.
Thank you.